Hey everybody, here's our first tutorial in Max. You should have already downloaded this beep test patch and verified that you're getting sound in Max. If not, please go back to that email, download this patch, follow the instructions, and make sure your sound is up and running, and then come back to this tutorial. So after you've tested the patch, you should immediately hear some synthesis like this. You can turn off the synthesis by hitting this DSP off button. You can also adjust the volume here with this volume slider. And you'll notice immediately that this is very much like VCV rack, and there is modular synthesis built into Max. We're not going to be working with that, but I thought I wanted to start here so that you were starting from some familiar territory. You can see that these are the same kind of modules we were working with in VCV. We have an oscillator. The output of the oscillator is going to a low-pass filter. The output of the low-pass filter is going to a stereo output, which is how we're hearing the sound. We have signal monitors so that we can see what our LFOs are doing. We can see what our audio signal is doing. And here we've got an LFO modulating another LFO, modulating a third LFO, which is sweeping the cutoff frequency. It's designed a little bit differently. It's laid out a little bit differently, but conceptually, it's exactly the same. So let's take a look at some of the basic operations in Max through this beep test patch. Before you do anything else, there's a couple of options that you need to make sure are set. And once you set these, they will stay that way. You won't have to reset these each time you start Max. Go up to the options window, make sure auto fix width is off, and make sure segmented patch chords is checked. And from there, we can just start working. So just to look at how things work in Max a little bit differently than VCV. If we click and try to drag these modules around, we can't. If we try to delete a chord or make a new chord, we can't. That's because our patch is locked. In Max, we have a locked mode where we can interact with the controls. And then we have an unlocked mode where we move things around and make new connections with chords. And if you create a chord and you don't want it, you can hit the escape key and that'll delete that chord. So you can click on a chord and hit the delete key. That will delete the chord. And then to make a new chord, you go to any inlet or outlet, hold your mouse over it, click once. That starts the chord. Then click again anytime you want to make a bend in the chord. And then when you're over the inlet that you want to connect to, click again, and that will make the connection. Unlike VCV, your dial settings are not automatically saved. So if you make some change that you want to keep, for instance, I'll lock the patch, turn my DSP on, and I'll change the offset of my low-pass filter. Okay, I like the way that sounds. So in Max, in order to save that so it's there the next time the patch is open, I have to go over here to Show Snapshots, open up the snapshot, click on the preset that I want to save it into, and go down here and say Take Snapshot. So now that change has been recorded into this snapshot. But this also shows us one of the nice things that Max has that VCV doesn't have, which is the ability to have multiple snapshots. So if I turn this on, I'll click on the arrows here to switch between these three snapshots. Aha, I recorded the DSP off into this snapshot as well, so I'm going to turn it back on. There, now I can switch between these three snapshots. And so, unlike VCV, you can save within any patch multiple variations of the sound. Now to add a new module, it's a little bit different as well. We unlock the patch, and these modules for synthesis are called beep modules. They're here under the B menu, and they're categorized. So if we wanted to add another LFO, we can go down to LFO, choose one of the LFOs offered here, for instance, LFO 3, and take its signal output and, for instance, modulate the resonance of our low-pass filter. And I can arrange things on the screen so they're a bit more logical looking, and then lock the patch, turn up the control voltage amount so that this LFO will be affecting the resonance, and listen to what we have. If we like what we're hearing, we can make a new snapshot here. So I'll turn it on, make a new snapshot. And now that new sound has been saved here as another snapshot. Now you notice there's an empty circle here. That means that this snapshot is currently being saved as an external file somewhere else on the computer. You want to click that circle so that it's saved in your patch. That way, if you share the patch with someone else, your snapshots will come with it. And now we have 4 different sounds to choose from. But just like in VCV, these are all interactive controls that you can mess around with in real time. And the patch keeps working when you unlock it. So if I wanted to add another LFO, I'll add a different type of LFO, one that's got a built-in meter. And I'll connect it. And then lock the patcher to make adjustments. Very similar to VCV. We're not going to be using this beep capacity, but it's there for you if you want it, and we can, you can integrate it into your creative work, certainly, if you want to. So we're just going to only retain one object from this, which is the audio output. And the rest of this we're actually going to delete. So I'm going to save this patch, and then I'm going to unlock my patch by unlocking the lock. The other way to unlock is to hold down the Command key, that's Control on Windows, and click in blank space in the patch. That will unlock. A third way to lock and unlock your patch is Command E, that's Control E on Windows. And just highlight all this stuff, delete it. And I'm just going to keep my audio output here, and then I'm going to save this as another name. I'll save it as, and you'll see why in a minute, I am, you are, tutorial. Okay, so the features of Max we're going to be looking at, the reason we're looking at Max is because it's another node-based environment. It's not timeline-based, but unlike VCV, which is limited to synthesis, Max gives us a whole range of possibilities. Possibilities for interactivity, possibilities for non-linearity, possibilities for generative processes and algorithmic processes that are difficult to implement in a timeline-based environment, but are much more logically pursued in a node-based environment, such as this. So I'm going to take a group of audio files, and you can download these and work with my audio files for now. Those are available on Blackboard. And these are the I am, you are audio files. There's 28 audio files. I'm going to select them all within the folder, selecting all 28 files, click them and drag them into my Max patch. And now here I have 28 audio files that are now all accessible in my patch. And it's quite a tall list, so I'm just going to grab by the lower right-hand corner. I'm doing this with my patch unlocked. Grab by the lower right-hand corner and just squish them up so that I can see all of them, but they don't occupy the whole screen, like so. I'm going to connect them to the audio output. So I'm going to click here. the first outlet of my stack of audio files is labeled playlist channel 1. Click it, connect it to the left inlet of my audio, and then here I have my signal channel 2. Click it, connect it to the right outlet. So I've made an audio connection from these samples to my audio output. Lock my patch, turn my DSP on, and now I can click any one of these arrows and hear the audio file. I am, you are. Now we see here that my volume is a little bit too low, so I'll turn it up. I am, you are. And now if I want to keep that audio setting, I need to make a snapshot for that. So I'll make a new snapshot. And since the old snapshots are no longer relevant to this patch, I can delete those with the minus key. So I'm just keeping the one that sets my audio level. And I'll click the circle so that it's saved with my patch, so that if I were to move this patch to another computer, my volume settings will be saved. And that's the only setting that's saved in this snapshot right now, is just that volume level. I'll save my patch. You want to save a lot, save as you go. Just like working in Ardour, you'd want to save your project regularly, just in case it crashes, just in case something bad happens. So I can access these white audio files. Dialectic, pain, creeping, without hope, by clicking their play buttons. And that's good, but not particularly useful. So how do we make this more useful? I'm going to create a little bit more space on my screen by unlocking the patch and actually compressing this so I can't see all of my files at the same time. And now you see I have a scroll bar on the right, so I can still scroll through and get to all of them, but I can't see them all. The power behind this is I now have what's called random access to these sound files. I can access them in any order. I can access them at any rhythm. And that's the beginning of how we're thinking about the difference between this node-based audio and a timeline-based audio like Ardour, where one thing necessarily follows the next thing, necessarily follows the next thing. Now, when I say random access, I don't mean you have to access them randomly, but actually that's how we're going to start. So first of all, let's look at a couple of structures in Max. I'm going to unlock my patcher. I'm going to hit the letter M, and that creates a message box. And a message box is some place where I type a message that I want to send to some object. So if I want to play the 6th sound file here, I can just type 6 into my message box, and now the message 6 is contained in this box. I connect the box to where I want the message to be sent, lock the patch, and now the message box becomes a button that sends the message it contains. Black, black. So every time I click this, it sends the message 6, which triggers the 6th sound file. Before we go any further, I want to have you format your font to make it a little bit easier to work in Max. So unlock your patch, click in any of the gray space here so no objects are selected. Go up to this little format paint bucket here, and let's choose a font that is fixed width, meaning that the width of all the characters and the spaces are the same. I use Monaco. Your computer might not have Monaco. Some other fonts that will do this for you are Courier, Andel Mono, and if you're on Windows, you can just Google a list of fixed width fonts on Windows, and you'll get a list of names of fonts that are in there. Courier, Courier New, American Typewriter, there's a whole bunch of them, but the point being that you want a font where the spaces are as wide as the letters, because spaces are really important in Max, and so it's important to be able to see them on the screen. And I like to make my font size a little bigger too. Go up to like font size 14. So I'm in Monaco 14. You might have some other font name here, but the point being, when you type into a message box, I'll make a new message by hitting M, and I type something in. And I'll click the box and make it wider. You can see the space is nice and wide. Most fonts have a narrow space, and that's going to make it harder to work in Max. And this is something you're going to have to do every time you create a new patch. So just get in the habit of clicking in the white space, clicking the paint bucket, choosing a monospace font, and making it a little bit bigger. So I can create multiple message boxes. I can highlight this message box, and there's a number of ways to copy things. I can hit Command D to duplicate. That's Control D on Windows. I can copy and paste it, so Command C, Command V. I can hold down the Option key and click and drag. That's another duplicating tool. And I'll just connect all of these up, and I'll put, whoops, I created a wild patch cord, so you can hit Escape. The other thing, if you have a wild patch cord, is you can Command click in the blank space. That'll get rid of it. And I'll do 6, 7, 8, 9, lock my patcher, and I can trigger these files. Black, confused, dialectic, improbable. Right, so we're able to access the sound files interactively. So already we have an interactive system here. I mean, this is a sampler. You could actually use something like this in performance. Dialect, dialectic, dialect, dialectic, confused, dialect, improbable, dialectic, black. Right, and that's fun, and you might want to play with performing things like that. That's not where we're headed today. I'm actually going to take these message boxes out for the moment, and let's look at how we might randomly select from these sounds. Well, in addition to message boxes that are created by the M, and I'll make a little note over here. And I type that into a comment that I created with C. We can also use the N key to create a new object. And objects are different than messages. And you can see they look different. They look similar, but different enough that you can tell the difference. A message has these rounded corners and no bars on the top and the bottom, whereas an object has gray bars on the top and the bottom. I'm going to make a comment for this. This is N for new object. And the first object we're going to learn is the random object. So I'll say random. And it auto-completes it for me. It knows what I'm typing. Let's look at that again. I'll delete it. If I just type R-A-N, it gives me a list of everything that starts with R-A-N. And at the top of the list is random. It's the one I want. I can just double-click that, and it will put it in for me. And random is an object that creates random numbers. So we have to tell it how many. What's the range of random numbers we want to create? Well, let's look at how many audio files we have here. We have 28 audio files. So I'm going to create 29 possible random numbers. Why? Because random always includes the possibility of 0. So random 29 means it's going to generate a random number between 0 and 28. Now the nice thing about 0 is, to this sample player here, to this playlist object, it means stop. So this randomizer contains the possibility of stopping a sound that's currently playing. Now, how do I trigger this random number? Well, it's another object called the button. Hit B and it creates a button. We'll put that over here. And a button sends a signal that in Max is called a bang, and it causes an object to do whatever it does. So in this case, when I hit the button, the random object is going to generate a random number. And if I want to see that random number, here's one more new object called an integer number box. We create that with the letter I. An integer number box. So we'll take the output of the random, pass it into our integer number box, and the number just gets displayed there and passed along. So we're going to click the output of our number box and pass it into our playlist. And this object is called the playlist. And just to clean up, I'm going to highlight all of these by dragging a box around them and hitting Command Y. That's Control Y on Windows. And that's just going to line them up neatly. And I can take this and stick it down here as well. So let's see what this does. I'll lock my patch, click my button, and I'll hear a randomly selected sound file. Confused. Click again, I'll get another randomly selected one. Hope. And another tomorrow. And another fusion. Right? So Every time I click, I get a random number between 0 and 28, a total of 29 possible values. Now, like dice, this does include the possibility of a repeated random number. I might get 5 twice in a row, or I might get 5, 4, 5. And we can look later at how to get non-repeating random numbers, but for now this contains the possibility of repetition. Okay, so what can we do with this? Well, we can immediately create a generative cut-up with just a few more steps. Let's take a message box and connect the fourth outlet of the playlist to the right inlet of the message box. Let's click that message box and make it nice and wide. What is this? This is the playback notifications given to us by the playlist object and tell us what it's doing. It's going to tell us what file it's playing. It's going to tell us when that file stops playing. And the right inlet of the message box just turns the message box into a text display on our screen so that we can see what's being passed out of this object. So we'll lock our patch, hit the random again, an army. And it tells us file 24 started, and then it tells us when file 24 is done, and also tells us where that file is located on the computer. Fusion, 22 is started, 22 is done. So how can we use this information? Okay, I'm going to learn another new object. So I'm going to hit N for new object. This object is called route. And what route does is it looks for words in messages. So I'm going to route done. And that means for the message that's coming in, look for the word done. And if the message starts with the word done, send out the rest of the message. But we're not interested in the rest of the message at the moment. I'm going to use the left outlet here. I'll get rid of this. We don't need to. So I'll keep it. Just shove it over to the side here. So I'm using another button here. Right? When the message starts with the word done, press this button. And I think you know what I'm going to do. I'm going to take the output of this button and I'm going to connect it to this button. And since we have segmented patch cords turned on, I can make this a nice, neat loop by going around. So now, every time a sound file finishes, we get a new random sound file. Let's see what that sounds like. You are a battleground. Black. I feel beetles without hope tomorrow. Okay, and there's actually no way to stop this at the moment, so we're just going to break that patch cord to stop it. So that's already kind of interesting, right? We're already getting this poetry just by randomizing the text. But the rhythm isn't great. Things are a little bit too spaced out. It's nice to have some spaces, but it would also be nice to have some quicker rhythms in there. So one of the nice things we can do in the playlist object is we can set the range that we want to play back. So all this silence at the end won't be played. It's going to play from the beginning to the end of the yellow section. And I can leave space on some of them, but I can also make some of them quite tight. And these settings you make will automatically be saved with your patch, and I'll show you ways later where you can create multiple settings of file durations. And of course, you can interrupt words in the middle. You can start words late. You can do anything you want with this. You can have just a tiny little speck of sound. But for right now, I'll keep the words pretty much intact. So now let's remake this connection. And I'm going to add a message with a 0 in it so that I have a control where I can stop things. And actually, I'll also add a message with a 1 so that I can always start from sample number 1. And so I'll start it off by saying, I am full of life. Love, I feel improbable. I feel improbable. An army, white, a battleground. Hope, white, confused. Love, I am doubtful. Black, tomorrow. Right, and my 0 is actually still not good enough to stop things, because when I hit 0, it will report that the currently playing sound file is done. So we're still stuck in an infinite loop. Let me show you another object that'll just let us stop things when we want to stop things. It's the GGate. If you type GG, it'll automatically come in. And GGate is just a way of switching the flow of things. So we'll take the output of this button, put it into the right inlet of the GGate, and we'll pass the GGate up here to this other button. And I'll make one over here. This is a new object, GGate. And when we click the GGate, it switches. So it's like switching a train track. When I click this button will flow out the right outlet and go nowhere, effectively stopping our loop. So I'll engage the gate. Missing something. Finished. White. We are confused. Fusion. Thoughtful. Hope. And there it ends. Great, so this is pretty interesting, and yet it's just the very, very, very beginning. So I mentioned before that it's possible for us to generate random numbers without repetition, and that's an object very similar to random. It's called earn. So I'm going to pull my random object out of here, stick it off to the side, and with the N key create a new object and type in URN, which is earn, and for some number of files, earn 8. So that is going to give me random numbers without repetition. It's going to give me the numbers 0, 1, 2, 3, 4, 5, 6, 7, a total of 8 values including 0, with no repetition. And when it's done, it's going to output a bang out of its right outlet to report, hey, I'm done with all my numbers. It also needs a message, clear. And clear will allow the earn to start over again after it's used up all of its numbers. So I'm going to go down here and close my gate, and we'll hear the first 7 sound files in a random order with 0 as a possibility. So it is possible we won't hear all of them, because when 0 is sent out by the earn, nothing will play. You are confused. We are. I am. And then we got the 0, so we didn't hear all of them. So we can clear this and get another little poem. You are. Well, that's it. That's all we got, because it generated 0. So what if we want to avoid that generation of 0? Well, let's take a look at another new object that'll help us with that. I'm going to compress my playlist even further to give me more screen landscape here, and introduce a new object, plus. And plus is simple mathematical addition. So plus space 1 will add 1 to any number. And I'll put it here under my earn 8. So just to review why we're doing this. And by the way, Command J will fix the width of my object. If my object is too wide or too squished, hit Command J, Control J on Windows, and that will resize the object box to what's typed in there. So earn is generating random numbers between 0 and 7, and 0 is cutting our poems short because it causes our playlist to not play. So by adding 1 to any number that comes out of earn, I get an effective range of 1 through 8. So now a 0 generated by earn becomes a 1 going into the playlist. Now we're going to hear 8 files in a random order. So let's clear our earn so that we're starting fresh and all 8 numbers are available to us. And let's hear it go through its thing, and then watch for this button to be triggered when it's used up all 8 values. Black. You are. I am. dialectic, white. We are, I feel, confused. There we go. A little poem of 8 samples, and then it bangs when it's done. And no values were repeated. It gave us 0, 1, 2, 3, 4, 5, 6, 7, which we added 1 to, which gave us 1, 2, 3, 4, 5, 6, 7, 8. So we heard the first 8 samples. And you may have realized, of course, you can put any value in here that you want. For instance, if you don't want to hear sample number 1, 2, 3, let's see what we got here. White, I feel. Okay, so let's say we want to start with sample 4. Then I'll just add 4 to the value. So when earn generates a 0, it's going to trigger sample 4. When earn generates a 1, it's going to trigger sample 5. Need to clear my earn because my earn is already exhausted, and now we'll hear it. I feel thoughtful, pain, improbable, confused, black, dialectic, white, and it's done. So pretty interesting, getting some pretty interesting results without having done too much, but we don't have a lot of control here. We're doing random access randomly, which is fine. And randomness, particularly if it's used well, can be really interesting. But I want to add another element to this, which is the element of probability. This is one of the most powerful tools that we can use in generative nonlinear work. Rather than having every transition from one sound to another be equally likely, we can make some transitions more likely than others, some transitions impossible. And this requires a little bit of conceptual work. So I'm going to save this, and I'm going to save as under a new name. So I'll do a save as. So now I've still got the work I had before saved in that previous file, and now I can really mess with this, but if I ever want to, can go back to this simple earn and random example. Because I'm not going to be using the earn or the clear or the random. I'll do away with this message box. What we're going to do here is look at a new object that allows us to make probabilistic transitions between the different samples. And it is called prob, P-R-O-B. And what prob does is it contains a table of probabilities of transitions. So before we go into how to construct a table of probabilities in prob, let's take a step back and look at what I mean when I say probabilistic. So I've taken all of the sound files and I've put them into Adobe Illustrator. I just recommend doing this with paper and pencil. So I'm making a map of what audio files can lead to what audio files and how likely they are to do so. So for instance, we're going to hear I am first. And I am, I've decided, can go to any of these 6 files. So our text can be I am confused, I am doubtful, I am missing something, I am full of life, I am hope, or I am love. And I've just decided not to use these other files for the moment. And then from any of these, they can go to either back to I am, or more likely to go to you are. So while it's possible that our poem would go I am confused, I am doubtful, it's more likely that it would go I am confused, you are doubtful. And then we have an exit point as well. Love contains the possibility of going to I am, the stronger possibility of going to you are, but also the possibility of stopping. So our poem could be as simple as I am love, stop. Or it could be I am love, you are confused, I am love, stop. Right, so this is our table of pathways through the material. And once you build a table like this and understand how you want things to move, then you can go back into Max and instruct your prob. And I'll show you how to do that. I can close my snapshots tab, and I'll make a little bit of additional space here. All right, so prob gets instructed by messages. So create an M for message. And each message has three things in it. It has the start, the destination, and the weight. And by weight, I just mean the higher this number is, the more likely it is to go there. And I just send that message into prob by locking my patch and clicking it. And now prob has been loaded with one probability. If it gets a 1, it will go to 7. If we want to take a look at what probabilities are loaded into prob, there's another message called dump. And dump will dump all the probabilities currently in our prob to this window here, the max console. So I'm going to click on that, hit the X to clear it, lock my patch, and dump. And it says I have one probability in my patch to go from 1 to 7. Close this back up. There's one other message that we want to send to prob before we go any further, because we're going to do a lot of work creating these probabilities. We don't want to lose them. We want them to save with the patch. So we're going to set the embed, E-M-B-E-D, embed space 1 message. I'm going to send that to our prob. Lock and click it to send the message. Now, what does this mean, embed space 1? In computers, 1 means yes. 1 means true. And so we say embed space 1, meaning turn on embedding, or embedding true, or embedding yes, we want it. So when we send that message embed 1, we're telling the prob, yes, embed your table of probabilities into this patch. So when we save it, like I'm going to do right now, our probabilities are saved with the patch. And that way we won't build hundreds of probabilities and then accidentally close the patch and lose them. So let's take a look at what other probabilities are implied here. Well, we know that 1 can go to any of these numbers. So I can just make a bunch of messages. One can go to 7, 18. I'm going to Command J to fix the width. 19. Command J, Control J on Windows to fix the width. 17. 21. And 12. And I'm leaving these all 1 at the end because these are all equally likely, equally probable. And I'll show you a shortcut when you have a bunch of stuff you need to connect. You click the destination, you hold down Shift, and then you click everything that you want to send. And then when you're done, you have a wild patch cable, which you can get rid of with the escape key. And then if I want to send all of these messages at the same time, I can do the same thing. I make a button, I click the outlet of the button, hold down Shift, connect it to all of these messages, and then I have a wild patch cable, Command click in the blank space or hit Escape to get rid of it, lock the patch, click the button, and boom, all of those messages get sent into my prob object, and I can open up my Max window here, clear it, do a dump, and I can see, aha, all my probabilities are now loaded into the prob. And because I already clicked embed 1, they'll save with the patcher when I save it. That's great. So I'm going to take all of these and Command Y just to neaten them up a little bit and do my next set of probabilities. My next set of probabilities is that 2 can also lead to all of these same sound files. I'll just take this entire structure, connect it here, and change these 1s to 2. And you're watching this and saying, my goodness, this is cumbersome. Right, there is a quicker way to do it, and I will show you that later. But first, let's look at the explicit way. So I've got all these in. They're all connected to the button, and they're all connected to the inlet of the prob. I click the button, burp, they all send into the prob. Just to check that it's all in there, I'm going to clear my max window, dump them again, and now I can see I have all my probabilities from 2, I have all my probabilities from 1. That's great. So now, looking back at our table, we see that all of these have the possibility of going back to 1, or a higher likelihood of going to 2. So let's build that. So 7, 18, 19, 17, 21, and 12 all are likely to go back to 1. Right, 17 to 1 with a weight of 1, 18 to 1 with a weight of 1, 19 to 1 with a weight of 1, etc. Click my button, all those probabilities go in. And they're all likely to go to 2 with a stronger weight, more likely. So I'm giving them a higher weight value. Lock my patch, send those all in, better check on it, go over to the Mac console, dump, and we can see, okay, we have probabilities from 2, probabilities 18 going back to 2 or 1, going back to 2 with a weight of 2, going back to 1 with a weight of 1. Looks like they're all in there. So have we encoded the entire set of possibilities? No, because we have one more possibility, which is that if we hear the sample love, there's a possibility that it will stop. So let's encode that. Make a message that says 12 to 0 is a possibility with a weight of 1. Connect that, send it. Now we have our complete probability table built in our prob object. We've encoded this in its entirety. Now, there's one important thing to realize, which is we didn't leave any loose ends. In other words, we didn't have the possibility of going here and then having nowhere to go from there, right? Any place we can go has another place it can go to. We can go from I am confused to you are doubtful to I am love to stop. But at no point will it get stuck. And so when you're constructing these probability tables, that's part of why we work it out on paper first, because we want to ensure that we're not going to get into a position where we've gotten into a corner where there's nowhere to go. And we can look at that later. Actually, sometimes it can be interesting for a probability object to have nowhere to go. But for now, it's better to plan out all the pathways through the material. So now we're ready to plug this prob object into our structure here. So I'm going to delete all of my programming stuff. This is already done. I'll delete my dump and embed because they're already done. I'll take this up here and put it where the random object was and feed it in. And the only thing it needs is it needs to know where to start. And we'll start it with 1. Now, I'm sending this 1 both to the prob object and to the playlist because I want to teach the prob object that we're starting from 1, and I want to play the first sound so that when the first sound finishes, it sends a bang to prob, which will generate the next value. Sound file 1 plays, and then prob determines where it's going to go next. Let's hear it. Make sure our GGate is connected here and start it. I am hope. I am full of life. I am confused. You are doubtful. I am love. And there it is. Right? It got to love, and at love, it decided between the three choices that it had, I am, you are, or stop, it chose stop. So now we can look at what this means in terms of percentages. If we're on I am, there's an equal chance that it will go to any of these. But when it's on one of these, like let's say it's on hope, it's twice as likely that it's going to go to you are than it is to go to I am. If we think of that in percentages, it's 66% likely to go to you are and 33% likely to go to I am. But when it gets to love, there's three places it can go, and one of them is given a weight of 2. So it's 25% likely it's going to go to I am, 25% likely it's going to stop, and 50% likely it's going to go to you are. But fortunately, because of the way Markov chains are set up, we don't have to think about those probabilities. We can figure them out after the fact if we really care, but it's not actually important to think of it that way. We're just thinking a higher weight number creates a greater likelihood for the transition to go to that destination. So let's hear a couple more probabilistic poems here. I am missing something. You are hope. I am doubtful. You are hope. I am missing something. Okay, and of course we're only working with a handful of samples here, so it's kind of limited where it can go, but still there's, it's getting kind of interesting. So let's do one more exercise before we wrap up this first tutorial, which is learning some tricks to help us build a more complex probability table. So I'm going to take this prob object and remove it from the equation here and put it over here. And I'm going to get rid of this for the moment because you have this in the other version of this patch that you saved. And I'm going to comment it as first version. I'll make a new prob object. And now, because it's a new prob object, I need to give it the embed 1 message, so it's saved with the patcher. Click that. And another shortcut you can use, instead of locking your patch every time, if you hold down the command key, the control key on Windows, and click a message box, it will send the message without you having to lock the patcher. That's just a little shortcut. Once I've sent it, I can delete it. It's done. And let's take a look at a more complex probabilistic scheme here. So in this, I'm only using 2 of the starting places and 6 of the samples. Here, I have a much more complicated arrangement, but I'm going to get much more interesting possibilities. So I am can go to any of these 6. You are can go to any of these 6 and also these 3. I am can go to these 2. I feel can go to these 5. We are can go to these 3. And then from any of these, we can go to you are, we are, or I feel. These 2 always go back to 1. These 3 always go back to 1 unless they're 12 or 16, in which case they have a chance of going to stop. And these 2 always go back to 1. And then also there's a higher probability that these 6 will go to I feel than they will go to we are or you are. So we're going to need some tricks to build this table, because if we build it the way we did last time, it's going to be a nightmare on the screen. Let's look at that. So what we want to do is we want some message that starts with 1, because we're talking about where 1 can transition to. And then we have 6 different places it can go. So let's not type that in. Let's type in what's called a changeable argument. That's $1. And don't worry about the 1 in $1. It just means this is undecided. And then with a weight of 1. Command J to fix the width of that. So 1 something 1. And then in another message box, we can put all the things that we want to substitute that something. 5, 6, 7, 13, 18, 19. So when I click this message box, it's going to send all 6 of these values in rapid succession, and they will all fill in this changeable value, this changeable argument, and we'll get all 6 probabilities loaded into our prob. We'll try it, and we'll use the dump message to check and make sure that it's working. Clear the window, dump, and we can see, yes, all those probabilities went in. That's great. So now it's much easier to proceed because, for instance, 2 can also go to all of those. So we say 2, changeable argument, 1, send, and all of those probabilities have been created. And we can always check as we go, and indeed, they've all been created. And then 1 can also go to 15 and 24. Keep this list, set it to the side. Option, click, and drag is how I duplicated that. 2 can go to 12, 16, and 11, like so. And 3 can also go to 12, 16, and 11, like so. And 4 can also go to 12, 16, and 11, like so. Change that to 4, lock the patch, click that. And then 4 can also go to 17 and 21. (17) and 21. Take a look, make sure it's all in there. And you could go through this and make sure, but it definitely is all in there. And then we can look at the output side. And because I kept all of these message boxes, it's going to be easier for me to put that information in just by reformatting this. So 5, 6, 7, 13, 18, and 19 can all go to 2, 3, or 4. So now I change the location of my changeable argument. Now it's the first thing. 5 can go to 2 with a weight of 1. 6 can go to 2 with the weight of 1. 7 can go. 13 can go. 18 can go. And 19 can go. So I send this whole list, which will replace the first element in this list, like so. Sent, and it's in there. They can also go to 3 with a weight of 1. Sent. And they can also go to 4 with a higher weight. Sent. Okay, so these probabilities are all entered into the prob. I'm done with this. Then 15 and 24 only ever go to 1. Sent. And I'm done with this. 12, 16, and 11 only ever go to 1. Sent. That's not true. 12 and 16 have another destination, but as a group, they only ever go to 1. And then 17 and 21 also only ever go to 1. Sent. So the only other probability I haven't put in is 12 can go to 0 sometimes. And 16 can also go to 0 sometimes. And I realized I made one mistake, is that 12, 16, and 11 have a high probability. Now, as a group, that doesn't matter. But because there's another option, it just means that with 12, it's twice as likely that it'll go back to I am than it will to stop. So I can just re-enter that probability. If you make a mistake, you can just overwrite it. So let's take a look inside first. I'm going to open up the Max window and dump it and find that error I made. So yeah, 12, the probability of 12 going to 1 is recorded as 1. That's not right. It should be recorded as 2 because it's a higher probability. Record it, dump it again, and now take a look. Yes, now my probability of 12 to go to 1 has a weight of 2. So my probabilities are totally loaded and we're ready to go. And now we're going to get a much more interesting probabilistic composition. Can delete all my messages. I'm done with them. Take my prob up here too, label it. Plug it in. We'll take this one, connect it to both the probability and the playlist so that we're teaching the probability where we're starting. We're also playing the sound that starts us. Lock my patch. I am an army. I am creeping. I am confused. I feel full of life. I am doubtful. We are pain. I am missing something. You are doubtful. I feel over. I am white. We are love. And there we go. It chose the stop option. So let's run it again and see how differently it comes out. It's going to, because it's based on probability, it's going to have similar patterns within it, but the details will be different. I am an army. I am creeping. I am black. I feel love. A short one. So this is just the start of thinking about organizing material in a different way. Not making every decision, but making a sphere of possibilities within which the computer does some of the fine decision making, but we have created an overarching structure. And this, I should just say, this exercise, this I am, you are, this is a great exercise that comes from a technique called instant songwriting, where you can create really compelling lyrics, or at least seeds of lyrics, by using kind of a cut-up method and using these sort of starting prompts, I am, you are, we are, I feel, I think, things like that. And it's, of course, one of very many techniques, but I thought it would be a nice place for us to begin. We'll do an exercise based on this that we'll talk about on Discord, and I'll write up for you on Blackboard. So obviously, there's a lot of information in here. Take this slowly, ask me a lot of questions, play a lot, experiment a lot, use my sounds for now, and in the next tutorial, we're going to look at how I got these individual sound files. Don't try to do it yourself yet, because it can be a very time-consuming process to chop up a sound file in this way, but actually Audacity has some tricks in it that make it quite a bit faster.